Okay, so quite a few of you had problems with simplifying the circuit that's shown on the screen. So I'm going to quickly run through it and see if I can explain some of the things regarding series and parallel connections. So remember, when two resistors are in series, the same current is going through them. And when they're in parallel, the same voltage is going through them. So let me just draw a simple circuit. With three resistors, and we'll talk about the relationships between them, and we'll say there's a battery on one side. So we got R1, R2, and R3. Okay, so if I draw any current that comes out of the battery, it's going to go up from the positive terminal. Remember, the positive terminal is alongside, through resistor 1, and then it's going to get to a junction there between R2 and R3. And what's going to happen at that point is that the current's going to split up into two parts. So that may make one green and one blue. So the blue current's going to go down through R3. The green current's going to go down through R2. And then at the bottom junction, they're going to combine back together again and give us the same current that we had coming through the battery. So if you look at this, which ones could be in series? Or remember, they're in series if they have the same current going through them. So if I look R1, R2, and R3, none of those have the same current going through them, so they're not in series with each other. Okay, how about in parallel? Okay, well, if they're in parallel, then there's nothing but wire in between the top and the bottom of the two resistors, because that's the only way they're going to have the same voltage across them. So if I look at the bottom of resistor 2, you can see there's only wire there. If I look at the top of resistor 2 and our resistor 3, there's only wire there. So those two are in parallel. So resistor 2 and resistor 3 are in parallel with each other. Resistor 1 is not in series with resistor 2, nor is it in series with resistor 3 because the current is different. Let's draw another sample one. So let's say I come out and let me do something like that. So I don't know, R1, R2, R3, R4. Okay, and drawing my different color currents. So see, let's do red current coming through I1. It gets to a junction where two wires meet, and then it's going to split up. So I'm going to have one, it's a purple one, hard to see, going down through resistor 2, and then a blue one going through resistor 3. And if we look, that blue one is also going to just turn the corner. There's no junctions there, no other wires coming off. And it's going to go through resistor 4. So I would say, okay, in this situation, R3 and R4 are in series with each other because they have the same current going through them. You might look at this picture and you say, well, hey, resistor 2 and resistor 4, those guys are in parallel because it looks like they're parallel to each other. But remember, if they're going to be in parallel, I have to have nothing but wire in between the top of them and nothing but wire in between the bottom of them. So if I look at the bottom of them, between 2 and 4, there I've got nothing but wire, so that's fine. But if I look between the top of 2 and 4, I've got a resistor in between, right? So those two cannot be in parallel. All right, so let's try and use those rules and go through the circuit that we have down at the bottom. Okay, I'll pull it up. So we've got 7 resistors. We're going to simplify it till we get down to just one resistor. So let's start off, let's draw our different currents because that's going to help us think about this. So let's make the total current. So usually we call it the total current when it comes out of the battery. Let's make that red. So it's going to go through R1, and then it's going to get to a junction right up there. When it gets to that junction, it's going to split up into 2 bits. So let's make one of them blue. So that blue current's going to go all the way down through R2 and R3. There's no junctions in between 2 and 3, so it doesn't change. And then, let's see, let me do a green one. Going over, that green one is going to go through R4. And then it gets to another junction, right? I got 2 wires splitting up. And so see, I'm going to have to choose two different colors. So let's make sort of this magenta, hot pink one coming down through resistor 5. And let's see, what other color can I use? Let me try dark blue. So then I have a dark blue one that comes down through 6 and 7, and it comes back. So when it comes back to this bottom junction here, now it joins back together to form the total green current. And then the green current and the cyan current come together, and they form back to the red current. So we still then we have I total going back down into the battery. Okay, so it's going to be simple for us to look at this and say, okay, what's in series and what's in parallel? If it's in series, they're going to have the same current going through them. So if I look at my picture, you can see that 2 and 3, those have the cyan current going through them. 6 and 7, those have the dark blue current going through them. So 2 is in series with 3, and 6 is in series with 7. So for those ones, we can just add it together. Make my pen size a little bit bigger so it shows up a bit better. So we'll call, if I combine R2 and 3 are in series. In series, they just add directly. So it's just going to be R2 plus R3 is equal to 4 plus 8 ohms. So I get 12 ohms. Okay, and I can do the same thing for 6 and 7 are in series. Again, they have the same current as each other. So we'll call that R67, just to remind us which two we're combining. R6 plus R7 is going to be 2 plus 2 equals 4 ohms. Okay, so after we've done that, then we're going to redraw the circuit. And we redraw the circuit, we're going to replace R2 and R3 with a single resistor, R23 at 12 ohm, and R6 and R7, we're going to replace that with a single one. Okay, so let me redraw this. So we've got our 5-volt battery. We've got R1, which is 4 ohms. Then we're going to go down now through a single R23, which is 12 ohms. Then we're going to go across through R4, which is 10 ohms. And down through R5, which is 4 ohms. And then finally, we're going to replace those two resistors, R6 and 7, with a single R67, which is 4 ohms. Okay, so now we're going to do, we can go through, we can trace our currents again. So let me go back. We got the red current coming out of the battery and into the battery on the other side through R1, gets to the first junction, splits up to a cyan one and the dark green one. Okay, and then it gets to the next junction at the top and it splits up to, let's see what were my colors. I had sort of the magenta one and the dark blue one. Okay, and let's see, those combine. Let's just finish it off, give us that current there. Okay, so we still have 1, 2, 3, 4, 5 different currents going through here. All right, so is there anything that's in series? No, because no two of those resistors have the same color current going through them, right? So none of them are in series with each other. How about in parallel? Okay, so you might say, well, it looks like R23, R5, and R67 are in parallel with each other. And if I look at it, so if I look at R5 and R67, between the top is just wire. Between the bottom, there's just wire. So R5 is definitely in parallel with R67. But what about R23? Well, R23, if I look at the bottom, I've got nothing but wire there. But at the top, I've got R4 in there, so it's not in parallel. So R5 and R67 are in parallel with each other, but R23 is not in parallel with them. So right now we're going to combine R5 and R67, which are in parallel. So in parallel, we have R5 and R67. Okay, and sometimes when I'm writing this, I will use the two parallel lines that indicates that the two are parallel. Okay, so it's just a shorthand notation. So when I combine them in parallel, I add the inverses. So R567 is equal to 1 over R5 plus 1 over R67, and then I have to take the inverse of my answer. Okay, so that's 1 over 4 and 1 over 4. They're both 4. So 1 over 4 plus 1 over 4 is 2 over 4. If I take the inverse of that, that's 4 over 2, or 2 ohms. Okay, if you're not happy with adding fractions, throw it in your calculator and get the answer that way. Okay, so I got 2 ohms. Right, never forget to take the inverse again at the end. All right, so now what am I going to do? I'm going to redraw my circuit again, and now I'm going to replace the two resistors R5 and R67, replace that with a single one. All right, so if you try to do this in your head, sometimes you can get confused about what's in series and what's in parallel. It really does help to always draw it out. Okay, so we've got R1, we've got R2, 3, we've got R4, and then we've got our R567. Let me put in the numbers. R567 is 2 ohms, and R4 excuse me, is 10 ohms. Okay, so now I want to do combinations. And again, let's just go through and do our currents again, just to make sure we're on board. So let me pick my red color. Is that red? I guess so. So it comes out of the battery, goes through resistor 1, gets to a junction, and it splits up. So if I'm consistent with my colors, I have green going through here. And now you can see that green current, there's no junction, so it's just going to turn the corner and go around. And we had cyan going down through here. Okay, and the green continues around, joins together with the cyan, and it gives us back the red one. Okay, so again, look at the picture. Are there any two that have the same color current going through them? If so, then they're in series. So if I look at that, I can see R4 and R567 have the same current going through them. There's no junction, so those two must be in series. If I look at R23 and say, is R23 in parallel with R567? Well, if I look at the bottom, just wire, so that looks good. If I look at the top, I got a resistor in between, so those are not in parallel. So the combination that I have to make here is that R4 and R567 are in series, and series is easy. I just add them directly. So what are we going to call this? R4567 is equal to R4 plus R567. So that's 10 plus 2, which is 12 ohms. Okay, what's the next step? Next step is draw your circuit again. And now we're going to replace those R4 and R567 with a single resistor. Okay, so I'm going to scroll up a bit. All right, so we've got our battery. We've still got R1. We've got R23. And we've got R4567. So we've got 4 ohms, 12 ohms, and 12 ohms. All right, let's do our color thing again for the currents. So we've got red coming out of the battery. I'm going to scroll this up a bit so it's above my command center there. All right, so there's my red coming out. It gets to this junction, it splits up into my cyan and my green again. and then at that bottom junction it recombines, and I go back into my I total. Okay, so are there any two resistors here that have the same color current going through them? No. So there's nothing that's in series. What about in parallel? Well, it looks like R23 and R4567 are in parallel, and we can check that. So look at the bottom of the wires. There's nothing but wire in there. Look at the top. There's nothing but wire in there. So those two guys are in parallel this time. Okay, so R23 is in parallel with R4567. Okay, so now I'm going to combine them. So I'm going to say, got to add up the inverses. So we can call R2, 3, 4, 5, 6, 7 is equal to 1 over R2, 3 plus 1, erase that, 1 over R4, 5, 6, 7. Minus 1. So that's 1 over 12 plus 1 over 12, which is 2 over 12. Take the inverse, I get 12 over 2, which is 6 ohms. And you might have noticed that both times in this example where we've combined two identical ones, so in the green up here I did 1 over 4 plus 1 over 4, I got 2. Here I did 1 over 12 and 1 over 12, I got 6. So when you combine two identical resistors in parallel, you get half the resistance. Okay, we're almost done now. We're down to 2 resistors. So redraw our circuit again. I've got R1. And I've got my big number there, R2, 3, 4, 5, 6, 7. Okay. And let's do our color thing again. So I come out of the battery, I go through R1 with my red total current. I get to this point, there's no junction, there's no other wire, so that red current keeps on going all the way around back into the battery. So now we know if they've got the same current going through them, they're in series. Okay, so R1 is in series with R2, 3, 4, 5, 6, 7. And that's going to take us down to 1 resistor. So we say that's our equivalent resistance, or that's our total resistance, whichever you want to call it, is equal to, just add them together. So let's see, let me remind myself. R1 is 4 ohms, R2, 3, 4, 5, 6, 7 is 6 ohms. So I'm going to have 4 plus 6, which is 10 ohms. Okay, so my total resistance for the circuit is 10 ohms. The total current, using Ohm's law, V equals I times R. So I equals V over R. Okay, so the V for the battery was 5 volts if you look back at the original problem. So I'm going to have 5 volts, and I'm going to divide to get I total. I'm going to divide it by R total. So I got 5 over 10 which gives us 0.5 amps. So our total resistance is 10 ohms. Our total current is 0.5 amps. Okay. One other question I often get is looking at when I go from the step up here where I simplified R4 and R567 together to make a single one. Why did I put my R567? So now I'm in the second bottom picture. Why did I put it where I put it? Why didn't I put it up here? Or why didn't I put it down there? It doesn't matter where I put it. I could put it anywhere I want as long as I don't go past a junction. So if you imagine wherever you have the two wires joined together, imagine you had a bead sitting on the wire and you're sliding a bead backwards and forwards. It can't get past anywhere where there's two wires tied together. So that bead, I can slide it anywhere I want on that wire. And I chose to put it in the position I did just because it made it more obvious to you about what the relationship was between R23 and R4567. So often when you're doing a problem on the homework or in a textbook, they'll put the resistor in a non-obvious location, so they might put it up here at the top, and so you wouldn't necessarily pick that it's in parallel with R23 because it's not actually drawn parallel to it. But if you look at the top, there's just wire. At the bottom, there would just be wire, and so you can tell that they're in parallel. Okay, I hope that that clarified things for you a little bit. Make sure you do some sample problems. There's some in the practice problem section on Canvas.